Hi, so today we're going to be talking about geometric series. So what is a geometric series? A geometric series can be defined by the sum starting at n is equal to 1 going to infinity of ar to the n minus 1, which is the same as a plus ar squared plus ar cubed plus etc., etc., etc. And if the absolute value of r is greater than or equal to 1, then the series will diverge. And for part B, if the absolute value of r is less than 1, then the series will converge. The formula for this can be written as, so we'll write the sum again. The formula is going to be a all over 1 minus r. And this is for absolute value of r's less than 1. And then for number 2, we're going to be calculating the sum going from I is equal to 1 to infinity of 5 to the minus I. And this is the same thing as rewriting this, where we have, going to infinity again, 1 over 5 to the I. And here we're going to write some terms first. So 1 over 5 to the 1, 1 over 5 to the 2, 1 over 5 to the 3, 1 over 5 to the 4, and dot, 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 dot. And as you can see here, we are changing by r is equal to 1/5. And 1/5 is less than 1, by the way. And we can see this because 1 over 5 squared is the same as 1 over 5 times 1 over 5. And also 1 over 5 cubed is 1 over 5 times 1 over 5 times 1 over 5. So you can see that r will be 1/5. And so then we can use our formula because we can use our formula. S is equal to a1 over 1 minus r. And this is going to be, our first term is a1, and a1 is going to be 1 over 5th all over 1 minus 1/5. And this is going to be equal to 1/4. And the question says, make sure to state why this series converges. The series converges because the absolute value of r less than 1 is 1/5 less than 1, and that works. So that's why that series converges. Okay, and then for the last part, they want us to rewrite this equation as a geometric series, okay? And so this needs to become something like 1 minus r, like that. So the first thing we're going to do is we're going to pull out some terms. We're going to pull out 1/2. And then when we do that, we need to divide all the terms by 2. So 2 over 2 minus x over 2. And we look at this and we say, okay, we're getting closer to the desired equation. So now we're going to pull out an x, 1/2 x, and that'll get us even closer. Okay, so here is our rewritten equation as a geometric series. And you can see that in this case, a is equal to 1/2 x, and r is equal to x over 2. And then to figure out for what values of x does the series converge, we know that the absolute value of r must be less than 1, and we know that r is equal to x over 2. So this must be less than 1, and then you have to do the other half of the inequality, x over 2 greater than -1, and you solve both sides. So that means x would be less than 2, and here x would be greater than -2, and then you combine those to write -2 is less than x, which is less than 2. So this means that in order for this series to converge, x must be in between 2 and -2.